Hello and good morning and welcome to the Carbon Trust Energy Storage Technical Webinar. My name is Doc Muirhead. I'm a senior engineer with the Carbon Trust. I've been with them now for 12 or 13 years, and I'm going to take you through this slide pack this morning. So the basic objectives of the webinar is to have a look at the energy storage technologies that would be applicable to an SME. We'll look at which is going to be the most suitable out of a range of technologies, and then we're going to major on trying to convey the information on that with regards to system use, system parameters, go through some examples, and then the future developments of that technology. And we'll end by going through a few slides on the Green Business Fund. Quick one about the Carbon Trust. We are obviously a not-for-profit organisation. With our mission is to accelerate the move to a sustainable low-carbon economy. The pillars on which we try and achieve that are through giving advice to businesses and governments and the public sector. We're also heavily involved in footprinting, where we measure and certify the environmental footprint of a range of organisations, products and services across the globe. And we also help to deploy low carbon technologies and solutions, part of which is this webinar today. So I think we need to add an air of caution just with regards to looking at energy storage. It's important to understand that there's no point in looking at storing energy or even generating and storing your own energy if your processes aren't as efficient as they can be. So energy efficiency has to be your first priority in terms of a cost-effective return on investment. Improving your energy efficiency is always going to come out at the top. So the basic premise then of energy storage, or the benefits of it, is that it will absorb and releases power, so it can then be generated and stored at another time. And so in effect you're able to store power when it is cheaper, and then use it at a time when your normal power coming from the grid is more expensive. Some of the most common technologies are well, they split into two branches. You've got your basic mechanical technologies, or otherwise you could term them as potential energy sources, and then the chemical and the common kind of battery storage, and we'll go through these in the next slide, just to flesh out some of the details of them. So for the likes of the compressed air, it's very simple. Air is compressed, becomes pressurized, and then is stored. When this is then released, it's typically to drive a turbine, and that in turn will generate your electricity. At the minute, it's really just utility scale only. It's quite an inefficient process. With regards to the flywheel, then you're using a high-speed, heavy spinning wheel to store electricity in the form of a rotational energy. So you would typically use cheaper electricity from the grid or from your own generation to drive the wheel up to speed, and then when you want to take that power off, then you use that spinning energy to drive a turbine. Again, utility only and very, very expensive. The pumped hydro, I'm sure you're all fairly familiar with. It just uses the height difference between two, usually lakes, and you use the off-peak cheaper electricity then to pump the water from the lower reservoir to the higher reservoir, and then once you want to use the electricity, then you release that water down, and it drives a turbine. It's not going to be a technology for an SME. And then really we come into the battery technologies. Typically, you've got the flow battery, the lead acid, the lithium ion, and sodium and zinc. The flow batteries, it is coming on as a technology, but there are some in commercial development, but they're not as commercially mature as the likes of the lithium ion. The lead acid, again, there are some systems available, some energy storage systems available using the lead acid battery, but it's and while they are cheaper, they do suffer at the minute from quite a low cycle rate, which I think in practical terms would exclude them from the majority of SME applications. The lithium ion, it's the most proven technology by a long way. There are a lot of battery storage systems on offer using lithium ion technologies, and they are popular because of their high cycle rate and the high energy density that you get with them. Again, then there's the sodium and the zinc batteries, but they're still at only really suitable for utility scale use. Again, they are not really a proven commercial technology as of yet. So really, in terms of interest to SME, it's really the lithium ion technology that is the only one that would be practical and suitable for use. So if we carry on looking in more detail then at the lithium ion batteries, as I said, it's the most common type used in the current commercially available systems. You'll have come across them over a wide variety of applications, but typically they're used in vast majority of consumer electronics and the automotive industry, and indeed it's the development of the automotive industry for electric vehicles that has been the main driver for the cost reduction in lithium ion batteries. They're ideal, as we said, is because of the high energy density, but they've got low standing losses. But still, they are only 90% efficient. So don't be thinking that 100% of the electricity that goes into the battery, you're going to get 100% out. You won't. They've also got a high tolerance to the cycle rate, i.e. the number of charges and discharges that they go through. as it said, costs are widely predicted to follow the same trajectory as PV costs. For example, I mean, in the last 4 years, the prices have dropped by 20%. I mean, certainly from the work that we have done with regards to photovoltaics, we have seen the prices drop from 2 or 3 years ago. You would have been paying £1,600 per kilowatt installed. We're now seeing systems coming through at 750 and £800 per kilowatt installed. So it would be no surprise then to see the cost of the lithium-ion batteries follow a similar trend. So in terms of how the battery storage would sit within a organization, your typical setup is you're going to draw electricity from the grid through the distribution board to service whatever load requirement you have. Using the battery storage, you're able to absorb the cheap electricity or at the time of the cheaper tariffs. You can then store that and wait until the higher electricity tariff comes around, and then you can draw that power off, which helps then offset the cost of the higher cost of the electricity that you're using. So that setup is then allows you then to import from the grid and export to the grid, which can add an additional revenue stream. The other option is the PV plus the DC storage, where the battery is connected to the PV side of the inverter. This will reduce the feed-in tariff that you would have from the solar PV, but there's no need or no requirement to inform your network operator, because you effectively with this setup you can't export onto the grid from the battery system. So all of the power from the solar PV is absorbed with the site load. It's a more complicated install, and in terms of using it as a retrofit option, it's normally not recommended because you can get a lot of compatibility issues with the solar equipment as well. The other option then is the PV plus AC battery storage. Similar setup to the previous example. You've got your the electricity generated by the solar PV through the inverter. Then that can, depending on where you are on your daily profile, that can either go through the inverter, converting it to the DC battery, or it can be used on site by your load demand. In this setup, you are able to export onto the grid as well as store the cheaper grid electricity as well. It has no effect on existing PV feed-in tariffs, and it is more suitable as a retrofit to an existing PV system. So in terms of looking at what a system payback is going to look like, we need to examine what the basic benefits of having energy storage are. It's important to remember that the economics of this are very, very specific to individual businesses. The typical paybacks are very dependent on the system type, the kind of load profile that you have, the tariff, electricity tariff structures that you're operating under, and your system charges as well. So it's a hard one to balance out. It's a hard one to be definitive on a simple payback for a typical SME. Every case has to be looked at on its own merits. But the benefits are the revenue streams that you can expect. One will lead down to your reduced electricity costs. If you're on a variable electricity charge under usually time of day tariff, then the storage allows you to store electricity when the costs are low, and then offset the higher cost of the electricity. The other benefit is using the storage if you have a PV system that currently exports some of the power generated, then the use of the battery storage will maximize the amount of power that you are using, and therefore the revenue. It will also increase that revenue stream. There's also the reduction in the third-party costs, so those charges that are leveled at you by the network operators. So there's the renewable obligations, or your GEOS and the other use of system charges. It's worth remembering that there is a portion of those charges are actually based on the amount of the electricity that you use. So being able to utilize the battery storage will or can reduce your energy consumption from the grid. There may also be an income opportunity by using a power aggregator company. They will set up a virtual network made up from a number of individual battery storage systems. They can then offer those services to the national grid, and by doing that, they're able to pass on some of the earnings from that to the storage system owners. So in terms of the battery system costs, or the capital cost, our current market analysis that's just carried out this month indicates that the current cost can range from £1,000 to £1,500 per kilowatt installed. Of course, there are going to be economies of scale will apply there, so that will be dependent on the size of the system that you're going to put in. Again, trying to put your finger on a typical system payback it's impossible. It just has to be done on the very specific and individual parameters of a typical business. The things, the variabilities that will have an impact on the payback, or obviously the kind of system that you choose, how much that costs, the your electricity consumption profile as well. It's very dependent on how that matches with typically if you have a PV array, then that's how that profile looks is very impactful on the payback too. And also, as we touched on, the electricity tariffs and any of the other system charges. But if you take account of all those variabilities, then typical system paybacks would be, again, in the range there of 5 to 15 years. I have to caveat that by saying that, I mean, the number of installs that would be looking at a payback of around the 5-year mark would be very, very few. Again, it's very, very specific on the individual business parameters. So in terms of the cost, I think it's worth highlighting again that the revenue streams from a battery storage system are dependent on those highly changeable variables that we've already gone through. We would urge that any battery storage business cases that are presented, they need to be based on a very robust sensitivity analysis that will look at the impact on the system payback, taking account of any changes in those variables, which, as you will know well, they can change from year to year. And similarly, we would urge a similar approach if you're entering into an agreement with an aggregator as well. There needs to be a good sensitivity analysis presented with any proposal. So some of the basic system parameters or kind of terminologies that you will come across. Looking at the system capacity, it's dependent. I mean, your choice of size of system is going to be dependent again on your profile, the size of any PV array, and what the site profile is from the PV against your electricity usage profile. There's the storage capacity versus usable capacity. Some of the battery systems are advertised, or some of the suppliers will rate the systems by their storage capacity, but really what you would need to be looking at is what the usable capacity is. Remember that the systems aren't 100% efficient, and you will get losses of 10 to 20%. Also, look at the product warranty. Obviously, there is some variability in the market with regards to what warranty is on offer. Again, the number of cycles is an important parameter as well. Some are guaranteed, but they can range up from a few thousand cycles, right up to the higher end of the market where there is unlimited cycles guaranteed. And finally, in terms just of the technology type, depending on your system use, you may look at the longer discharge and higher cycle flow batteries. There are a few installations of the flow batteries, but again, they haven't quite reached had the same commercial impact as the lithium ion. So we've got some examples of the battery energy storage, just fairly high level, but in kind of a SME setting, using just a battery system only to reduce the power drawn during the peak times from the energy network, and that type of system can also be used as an emergency backup. The benefits are as explained before. You're reducing your electricity demand at a time when the network is charging the most, but you're also offsetting your distribution use of system charges. Typical cost for that kind of battery storage is around the £3,000 per kilowatt, and you could expect a maintenance cost. They're very, very low. Typically, the units are pretty much plug and play. And then just a second example, just with one SME with an existing solar PV. So the kind of benefits that give is just exactly the same as example 2. And again, that can be used for emergency backup. The costs don't change. It's a similar sized battery system. It's worth remembering that those costs there are for the battery storage only. So if you were going to install it with a PV system, then you could add another £800-900 per kilowatt of PV installed. So in terms of where the market is going with the battery energy storage, I mean, as I said, the industry is predicting that the cost of the lithium ion batteries is going to decline for as much as 30 to 40% over the next 5 years. That's obviously going to have a major impact on the project cost effectiveness. That demand, that drop in cost, again, it's all down to or the vast majority of the drive for that is through the development of electric vehicles, just by virtue of the number of dedicated manufacturing plants that are have been built and are in the pipeline. Other things to watch out for would be the UK market reforms, which may allow SMEs access to the broader market and open up some additional income streams. Again, that would improve project payback greatly. Also, new business models as the competition in the market begins to increase in terms of aggregators, and it wouldn't be it wouldn't be unexpected to see new kind of business models coming up, centered around on-site battery storage. And also you can expect to see an improvement in aggregator, what kind of prices they can offer as well. But that's going to be fairly dependent on the types of deals that the aggregator can strike with the network operators. So to summarize in brief, again, just to stress the point, it only makes sense to look at this technology if your on-site services are as efficient as they can be. The lithium-ion battery technology it's a well proven commercial product and would be the most suitable for an SME. Remember that the costs of the batteries are falling, and they're falling rapidly, and this is projected to continue. So while they may not look like an attractive proposition at the minute, it won't be long before they will be coming down in terms of the payback. On the payback, that they are a project payback is very, very dependent on a number of factors, which can be very variable. So you just need to make sure that if you're going to go ahead with a project, that you've carried out a good, robust cost sensitivity analysis, and do that across the actual lifetime of the asset. I guess it depends on what kind of guarantees that you get with the batteries system as to what kind of asset lifetime you want to apply. And it's obvious to say, but the kind of project cost effectiveness is driven by the cost of the battery. So as they come down, that's going to improve as well. So on to the Carbon Trust Green Business Fund then, just a few slides to summarize. It's a scheme that's been operated by the Carbon Trust, serving SMEs across England, Scotland and Wales, doing that since 2016. It provides a combination of advice, training and direct contribution for the purchase of capital equipment. As said, only available in England, Scotland and Wales, but it is open to a wide variety of businesses. The only limitations on it are the domestic, the public sector and new build. Again, only open to SMEs. So as part of the GBF offering, we offer a range of energy efficiency training workshops. It's typically over 2 hours and will help you identify the no and low cost energy efficiency measures. And there's 3 or 4 of them coming up in October. The one in Hensel, I think that's aimed primarily at the construction sector. So just a couple of case studies of where businesses have come to us for support. This will have been an opportunity assessment where we've been approached by APS Metal to come to site and help them identify the top 3 recommendations. And they will have gotten a report which will have outlined what those recommendations are, what the costs are, and what the project payback is. I'm trying to see if they actually tell us what the recommendation was. Doesn't seem to. We also do offer implementation advice, which is, as it says, they're up to 5 days support where we will look at an individual project that you want to take forward, and we can go out to tender on your behalf to the green, to companies that are on our green business directory. So we'll develop the invitation to tender documentation, choose 2 or 3 suppliers to go out to tender to, and then we will assess the tender returns in terms of their technical and financial viability. So you have the implementation advice, then you've got the opportunity assessment, which are all highlighting cost-effective energy efficiency projects. And the 4th offering then is the capital contribution. It's for 15% of the capital cost of the project, up to a maximum of £5,000, and the project would have to pay back in less than 5 years. The process is straightforward. All you need to provide is a quotation from one of our accredited suppliers, and then your application goes for just the usual financial verification, and then the project goes through an internal technical assessment, just to ensure that the savings are there, and then the offers made. I think typically these can be turned around in less than a couple of weeks. Also, the energy technology list. It is a list of technologies that have been assessed and are offered. Well, there are a range of technologies heading from refrigeration right the way down to motors, drives, and heating. It's an enhanced capital allowance that you can claim on equipment that is on the energy technology list. It just means that you get a tax benefit in the year of the purchase of the equipment. So for an organisation that's spending £10,000 on a piece of equipment that's on the list, that could mean a tax benefit of just shy of £2,000. And there's all of the websites for the energy technology list there for you to follow, should that be of interest. So we'd talked about the Green Business Directory. This is a directory that we operate. The idea behind it is, I mean, it's clear from the work that we have done that there are a number of barriers to implementing energy efficiency projects, and they're usually made up from you're not quite sure if the supplier claims are true, or you can't, all the suppliers are very, very similar. And of course, you have little time to assess all of the options. But what the Carbon Trust then has done is seek to overcome these issues by supplying a list of accredited suppliers which have gone through our independent assessment, and we've looked to validate the supplier's skills, services, and also the claims that they make on the project. So you can go to the website, it's free to use. You can filter it and search for individual suppliers of the technology you're interested in your area. Also, we also still offer the interest-free loans for Welsh SMEs. They're loans from 3,000 up to 200,000, and we can offer £1,000 for every 1.5 tons of carbon that a project will save annually. They are designed specifically so that in the vast majority of cases, the forecast reduction in the energy will be equitable to the total repayment amount. Therefore, the energy that your project, or the cost savings that arise as a result of the project going ahead, that will cover the cost of your repayment, which are normally set at from 1 to 4 years. As with all these financial offerings, that they are subject to some eligibility and terms and conditions. So that's us through the slide pack now, and just ask if you have any questions at all.
We're just going to give it a few minutes for any questions that come in, and so we'll just place the microphone on mute just for a moment.
Oh, okay, thank you.
We've got one question here.
Okay.
You only discussed PV with storage. How about other renewables, small wind, etc.?
Yes, it's going to be there's going to be exactly the same offering or kind of system setups. It's just that the PV would be the commonest at the moment. But you're absolutely right. For the likes of small scale wind, it would be as equal a worthy project. The benefits would be exactly the same though.
Someone's asked if they can view the webinar again and have the presentation. The answer is yes. We will send out a copy of the presentation, and we will put a link up of the webinar so you can watch it again. And then we have another question. How far off is the hydrogen option, and is it something that you can compare to the other storage options at the moment?
Oh, that's one I don't think I'd be qualified to answer. If we can take a note of that, then I can ask that question of colleagues.
Yeah, we can take a note and then get back to the person who asked.
Yes. Okay. Great.
Okay, we'll just give it. Just if anyone has any final questions, just feel free to ask. And then if not, then we will go ahead and close the webinar for today. Okay, I think that's all the questions that we have today. And just remember, you can always, if you think of anything, you can send it to us, and Donna can get back to you after the webinar. But thank you, everyone, for attending today, and thank you, Donna, for a great webinar.
Thank you. Okay.